Hello everyone, I'm Madhura L from First Sem Honda section. Today's subject is civil engineering and the topic is drinking water treatment plant and its process. For the introduction, let us look into what is drinking water treatment plant. Drinking water treatment plants are used to remove particles and organisms that lead to diseases, protect the public's welfare, and supply pure drinkable water to the environment, people, and living organisms. In addition, they also provide drinking water that is pleasant to the senses, that is, taste, sight, smell, and provide safe, reliable drinking water to the communities they serve. Water treatment, as a word, originally means the act or process of making water more potable or useful by purifying, clarifying, softening, or deteriorating. And these are the places where drinking water treatment plants are used. First one, Akon International Engineering Training Consulting Inc., Ankara, Turkey. Gazi University, Ankara, Turkey. Nice University, Nice, Turkey. Plan Art, Ankara, Turkey. Research and Development Center, BioIntech Limited, Sofia, Bulgaria. Open University of the Netherlands, Herlin, Netherlands. First one, water treatment plants are installations where waste or dirty water is converted into better quality water through various physical and chemical processes. Wastewater treatment processes are designed to improve the quality of the wastewater. The various treatment processes may reduce: first one, suspended solids; second one, biodegradable organics, which can serve as food for microorganisms in the receiving body; third one, pathogenic bacteria and other disease causing organisms; fourth one, nutrients including nitrates and phosphates. And there are three widely used terminology refers to three levels of wastewater treatment, that is, primary treatment, secondary treatment, tertiary or advanced treatment. And the above diagram represents the flowchart of the primary, secondary, tertiary treatments. For the first one, primary or mechanical treatment, it is designed to remove gross, suspended, and floating solids from raw sewage. It includes screening to trap solid objects and sedimentation by gravity to remove suspended solids. This level is sometimes referred to as mechanical treatment, although chemicals are often used to accelerate the sedimentation process. Primary treatment can reduce the BOD of the incoming wastewater by 20 to 30% and the total suspended solids by some 50 to 60%. Primary treatment is usually the first stage of wastewater treatment. Now let us look into the secondary or biological treatment, which removes the dissolved organic matter that escapes primary treatment. This is achieved by microbes consuming the organic matter as food and converting it to carbon dioxide, water, and energy for the growth and reproduction. First point, the biological process is then followed by additional settling tanks to remove more of the suspended solids. About 85% of the suspended solids and BOD can be removed by a well running plant with secondary treatment. Secondary treatment technologies include the basic activated sludge process, the variants of pond and constructed wetland systems, trickling filters, and other forms of treatment that use biological activity to break down organic matter. And next, let us look into the tertiary treatment. That is simply additional treatment beyond secondary treatment. Tertiary treatment can remove more than 99% of all the impurities from sewage, producing an effluent of almost drinking water quality. The related technology can be very expensive, requiring a high level of technical know-how and well-trained treatment plant operators, a steady energy supply, and chemicals and specific equipment which may not be readily available. An example of a typical tertiary treatment process is the modification of a conventional secondary treatment plant to remove additional phosphorus and nitrogen. Now let us look into the steps of water purification. The last slides were about primary, secondary, and tertiary treatment. Now let us look into steps of water purification. And in that, the first one is coagulation. Natural and wastewater containing small particulates that are suspended in water forming a colloid. These particles carry the same charges and repulsion prevents them from combining into larger particulates to settle. Thus, some chemical and physical techniques are applied to help them settle. The phenomenon is known as coagulation. A well-known method is the addition of electrolytes. Charged particulates combine with ions neutralizing the charges. The neutral particles combine to form larger particles and finally settle down. Another method is to use high molecular weight material to attract or trap the particulates and settle down together. Such a process is called flocculation. Starch and multiply charged ions are often used. Now, for the second step, sedimentation. Let the water sit around to let the flocculated or coagulated particles settle out. It works best with relatively dense particles, example, silt and minerals, while flotation works better for lighter particles, example, algae color. A settling tank should be big enough so that it takes long time, ideally 4 hours or more, to get through. Inlets and outlets are designed so the water moves slowly in the tank. Long and narrow channels are installed to let the water snake its way through the tank. The settled particles, sludge must occasionally be removed from the tanks. The water is next ready to be filtered. Sedimentation is used in pre-treatment and wastewater treatment. For the third point, filtration. It is the process of removing solids from a fluid by passing it through a porous medium. Coarse medium and fine porous media have been used depending on the requirement. The filter media are artificial membranes, nets, sands, filter and highly technological filter systems. The choice of filters depends on the required filtering speed and the cleanness requirement. The flow required for filtration can be achieved using gravity or pressure. In pressure filtration, one side of the filter medium is at higher pressure than that of the other so that the filter plane has a pressure drop. Some portion of this filter type must be enclosed in a container. The process of removing the clogged portion of the filter bed by reversing the flow through the bed and washing out the solids is called backwashing. Now for the fourth, disinfection. Typically with chlorine can be the final step before discharge of the effluent. However, some environmental authorities are concerned that chlorine residuals in the effluent can be a problem and have moved away from this process. Disinfection is frequently built into treatment plant design, but not effectively practiced because of the high cost of chlorine or the reduced effectiveness of ultraviolet radiation where the water is not sufficiently clear or free of particles. Now, for the fifth point, aeration. Bringing air into intimate contact with water to exchange certain components between the two phases is called aeration. Oxygenation is one of the purposes of aeration. Others are the removal of volatile organic substances, hydrogen sulfide, ammonia, and volatile organic compounds. A gas or substance dissolved in water may further react with water. Such a reaction is called hydration. And for this sixth point, let us look into the need for wastewater treatment and environmental impact of untreated wastewater. Need for the wastewater treatment. The need for the wastewater treatment is evident in the growing water scarcity crisis. According to the United Nations, over 2 billion people worldwide lack access to safe drinking water, and by 2025, half of the world's population will be living in water-stressed areas. In addition, untreated wastewater can have serious environmental and health impacts. Untreated wastewater can contaminate rivers, lakes, and oceans, harming aquatic life and making water unsafe for human use. It can also contribute to the spread of waterborne diseases such as cholera and typhoid fever. In areas with limited freshwater resources, untreated wastewater can also be a major source of water pollution. Next is environmental impact of untreated wastewater. Untreated wastewater can have significant environmental impacts. When wastewater is discharged into the environment, it can deplete oxygen levels in water bodies, harming aquatic life. It can also contribute to the growth of harmful algae blooms, which can have devastating effects on marine ecosystems. In addition, wastewater can contain high levels of nutrients such as nitrogen and phosphorus, which can cause eutrophication. Eutrophication is the process by which an excessive amount of nutrients in water causes an overgrowth of plants and algae, harming aquatic life and making water unsafe for human use. And what are the health risks associated with untreated wastewater? Let us learn that. Untreated wastewater can pose serious health risks to humans and animals. Wastewater can contain a variety of pathogens including bacteria, viruses, and parasites which can cause waterborne diseases. Waterborne diseases can cause various symptoms including diarrhea, vomiting, and fever. In severe cases, they can be life-threatening. Waterborne diseases are hazardous in areas where access to medical care is limited, such as developing countries. And these are the benefits of wastewater treatment. Wastewater treatment offers a range of benefits to the environment and public health by removing contaminants from wastewater. We can reduce the risk of water pollution and the spread of waterborne diseases. This in turn helps to protect our natural resources and preserve the delicate ecosystems that depend on clean water. And for the future of wastewater treatment. As the global population grows, the need for wastewater treatment will only continue to increase. However, advances in technology and innovation are making wastewater treatment more efficient and effective than ever before. New treatment methods such as membrane bioreactors and sequencing batch reactors are improving treated water quality and reducing the energy required for treatment. In addition, new technologies such as sensors and data analytics are making monitoring and optimizing the treatment process easier. So, for the conclusion, wastewater treatment is an essential process that is critical in protecting our environment and public health. By removing contaminants from wastewater, we can reduce the risk of water pollution and the spread of waterborne diseases. This in turn helps preserve the delicate ecosystems that depends on clean water and ensure we have access to safe clean water for generations to come. As water scarcity becomes an increasingly urgent issue, wastewater treatment will become even more important. By investing in wastewater treatment infrastructure and technology, we can ensure that we can meet the growing demand for clean water and protect our planet and its inhabitants for years to come. And thank you all for watching my video.